This is the video solution for Topic 8 Acid and Bases for Normal ACAD 10-year series. First question. Sodium bicarbonate is dissolved in water. Indicator is added and the color is compared to the pH color chart, and it has a pH of 9. So which statement describes sodium bicarbonate? So pH of 9 is a weak alkaline. Alright, it's a weak alkaline because 7 is neutral. So between 8 to 10 is weak alkaline, and of course beyond 12 is strong. And of course for acid wise, below 3 is strong, between let's say 4 to 6 is actually weak acid. So answer is D. So the next equation is incomplete word equation. Okay, acid plus metal gives salt and what? So a metal always produces hydrogen gas, you must know that. Question number 3. A garden soil has a pH of 6.5. This is weakly acidic. Okay, weakly acidic. And cabbage grows best in 7.5, which is slightly alkaline. So when calcium hydroxide is added to the soil, which rule is correct? So the soil in the garden is a weak acid, and the cabbage grows best in the soil that is 7.5, which is a weak alkaline. And of course, calcium hydroxide has to be alkaline because you need to neutralize acid and bring the soil to become slightly alkaline. So it's B. Question number 4. The oxide of element X dissolved in water to form a pH of 5, and this is acidic. Acidic oxide can only be non-metallic. Alright, non-metallic and acidic because pH less than 7. Less than 7 is acidic. So answer is C. The soil 6.5, and after adding calcium hydroxide, okay, which plant needs calcium hydroxide to be added for the plant to grow well? Now when you add something that is hydroxide, the pH will increase. Okay, increase to above 7 because this is about pH 10 to 12. So you add a little bit. So 6.5, you add this one to increase the pH. So which plant grow best in the slightly alkaline? So of course something that is higher than 7, answer is B. Right, you want this one is pH greater than 7. So it's 7.5. Number 6. And all this aluminium, carbon, magnesium burning oxygen, oxides are formed. So what type of oxides are they? Now you must remember, under amphoteric there are 4 of them. One is aluminium oxide, zinc oxide, lead 2 oxide, and tin 4 oxide. So these are amphoteric. And for neutral, okay, neutral there are 4: CO, NO, H2O, and N2O. So these 4 are neutral. So all the non-metal, if it's not neutral, they are all acidic. All the metal, if they are not amphoteric, they are basic. So magnesium has to be basic because magnesium is a metal, but it's not under these 4. Aluminium has to be amphoteric, which is here. Alright. And carbon dioxide is acidic. So answer is B. Because carbon dioxide is under non-metal, but not under the neutral. Question 7. In an experiment, equal portion of lime are added to 20 cm³ of vinegar. How many portions of limes are required to neutralize 40 cm³? Now neutralize means pH 7. Okay, so down here you're referring to 20 cm³. 20 cm³ require 3 portions, right? Because this graph is for 20 cm³. So 20 cm³ requires 3 portions to get a pH 7. And if it's 40 cm³, now this is a trick question, this is not the same value. So how many portions do you need? Of course you need 6 times 2. 20 requires 3, 40 requires 6. Acid plus alkali, or you can also base wise, you produce the same thing, salt and water only. and this is called neutralization. Element X form a basic oxide, it has to be a metallic oxide. In this case, answer is B. Alright. Buildings made of calcium carbonate can react with acid rain. Carbonate and rain, and acid, of course, acid rain, they will react to form a gas called carbon dioxide. Because carbonate plus acid form salt, water, and carbon dioxide. You must know that. Number 11. Which row shows the type of oxide for each element? Now, acidic oxide has to be a non-metal. So it can be a carbon dioxide, sulfur dioxide. Basic oxide has to be a metal. So down here, all these are non-metals. The only one is this metal. So basic oxide must be a metal, so it's D. Compound X is used to control soil acidity. In other words, if the soil is too acidic, you add this. It has to be either calcium oxide or calcium hydroxide. You look for these two terms only. Alright, calcium oxide or calcium hydroxide. Answer is B. Acids can react with base, carbonate, and metal. That's why we call it MCB. So, when reaction does occur, which of them produces a gas? Alright, so metal acid does produce a gas, so this is correct. Carbonate does produce a gas. And of course, base, acid base produce salt and water only. So answer is C. So the gas when you react with carbonate is carbon dioxide gas. The gas we produce when we react metal is hydrogen gas. And of course, acid and base give us salt and water only. Baking powder is dissolved in water. And then UI is added to the solution, it turns blue-green. Now you must remember the color of the universal indicator: red, orange, yellow, green, blue, indigo, violet. So remember, it's 1 is very acidic, 7 is neutral, and 14 is very alkaline. So in between, roughly space out 3, 5. Here is about 10, 12. Alright. So about pH 9 here, blue-green. So this is a weak alkaline. Alright, the strong one will be 12 onward is strong, and 3 and below is strong. Strong acid, strong alkali. And those that is just below 7 is weak acidic, and just above 7 is weakly alkaline. So it's weak alkaline for pH 9. Structure question 1. Indigestion is caused by having too much HCl in the stomach, and antacids are taken to treat the indigestion, in other words, to react with acid. So one of the compound is actually magnesium hydroxide. Write a balanced equation to show reaction between HCl and magnesium hydroxide. They do not ask you for state symbol, so don't need to write. So a base plus acid give you a salt and water. To balance it, I need a 2 here, I need a 2 here, and then it's balanced. And this type of reaction, acid plus base reaction, is called neutralization. Don't forget how to spell. Okay, neutralization, very important. Acid base reaction gives salt and water, neutralization. Next question. Okay, letters are chemical symbol. They are chemical symbol. So let's look at chemical symbol. N refers to nitrogen. K refers to potassium. And P is phosphorus. Phosphorus is one element present in the fertilizer. Name the other two elements, of course, is nitrogen. Always refer to the periodic table if you are not sure, because they say that the letters are the chemical symbol. Once you talk about chemical symbol, you look in the periodic table. Okay, always refer to the periodic table at the back of the exam paper. Nitrogen and potassium. Okay, so farmer investigated the effect on the potato yield by adding different amount of fertilizer to the soil. He divided the field into 7 equal plots. He spread different masses of fertilizer across each Okay, and then the table shows the actual mass of phosphorus present in fertilizer and the potato yield, means how much potato is produced in terms of kilogram. So if you look here, as the amount of phosphorus added, like for example 0, it produces potato 1300 kilogram. If you add 10 kilogram of phosphorus, okay, then it produces 2006, which is more. At 20, it produces 3001, 30, 3004, and so on. Alright? So you observe that the last two values are the same. What does it mean? It means that if you add either 45 or 50, you either add 45 or 50 to the land, you realize that the amount produced is the same. Alright? So this is just want to highlight a little to you. Okay. To plot. So mass of phosphorus. Okay, 0 is 1003. So let's plot. Okay, let's plot all the figures. 0 is 1003. Then is 2006. 20 is 3001. And 30 is 3004. And 35 is 3450. And then 45 is 3005. 35, 45. Okay, 45 is somewhere here. 3005. And 55 is 3005. 55 is 3005. Okay. So it's also draw a best fit curve. So by plotting, you get 1 mark, and drawing best fit curve. Let's draw the best fit curve. It's a bit difficult to draw on the screen. Okay, try to fit through all the points. Alright, this is the best fit curve. So using your graph, give one reason why farmer decided to add 30 kg of phosphorus to each plot in future years. Why 30 is the best? 30 here. Why 30 is the best? Now I realize that when you add, every 10 you increase, there is quite a significant increase. And after 30, the amount increase is actually very insignificant. You see a difference between these two? Alright, the vertical is the amount increase. It's still significant amount here. So the amount increase from 30 onward is not very significant. Okay, the amount of increase in the yield of potatoes is not significant when more than 30 kg of phosphorus is added. So before you reach 30 kg, for example from 0 to 10, there's a big increase, a big jump. From 10 to 20, there's still a significant increase in the amount of yield. And then from 20 to 30, the yield is getting smaller. And from 30 onward, the yield is not significant, only a small amount. So therefore, if you add too much, you're not worth it actually, wasting your money. So the reason is this. Alright, not worth adding more than 30 kg of phosphorus. Okay, the back shows 4 below phosphorus. And what is 4? The meaning of 4. The number under each letter shows a percentage by mass of the element present. So in other words, the phosphorus present is actually 4%, okay, in the bag. Each bag contains 50 kg and only 4% belongs to phosphorus. So what will be that amount? To provide one plot with 30 kg and every bag only 2 kg belongs to phosphorus, so therefore I need 15 bags. Now the soil of this field is actually pH 5.5, and the cabbage requires 6.5. They need to remove some acidity or increase the pH to 6.5. So the chemical that is used to spread the field to raise the pH. Raise the pH means more alkaline, so it's actually calcium. This is the recall question, hydroxide. Okay, and this is like the another name given is called liming the soil. Okay, which is adding calcium hydroxide. Explain how the chemical name in D1 can bring about this change in pH. So what's so special about calcium hydroxide? So explain how the chemical name in D1 can bring about this change in pH. Calcium hydroxide is a base. It will react and neutralize acid, because acid and base react to form salt and water only. So the salt form is neutral, so therefore when the acid is reacted, the pH actually increases. Next question. Now what's apparatus X here? X used to add drop by drop, and of course this is called burette. Learn the spelling. Burette, burette. 20 cm³ of potassium hydroxide is transferred to an insulated beaker. Temperature is measured and recorded. Insulated means actually is they put some insulator so that the heat loss surrounding will be minimal, reduce the heat loss. And 2 cm³ of portion of dilute HCl is run into the beaker from the burette, and then they measure temperature change, temperature increase. And after that, another 2 cm is added. So each time you add 2 cm³, the temperature is taken. So you start off with 0, which is 21.0 degree. We add 2 cm³, temperature rise to 24.2, another 2 more, and after adding 4 in total, temperature rise to 27.4, and another 2 more, which is 6 in total, it reach 30.7, and so on. So 4 points have been plotted, and then the best fit line has been drawn. So you are supposed to plot the remaining 4, okay, and mark them with a cross, and then draw a best fit line for these 4 points. Alright, so 0 is 21. So let's for 0. 0 is 21, 21.0. So it's here. Alright, 21.0. Whereas 2 is 24.2, 24.2, 24.2. Because every square is 0.2. And whereas 4 is 27.4. 27.4, 27.4. And is 6, it will be 30.7. Whereas 6 is 30.7. 30.7, 30.7, it should be around here, 30.7. Alright? Yeah, and then you need to draw a best fit line. Alright, it's a straight line. Okay, extend this line to intersect, which is here. And from the graph, determine the volume of HCl required to neutralize the potassium hydroxide. Neutralize means where do they cut, where do the two lines cut at the highest point. So actually here, if you read down, the volume needed okay, around here, so it's about 6, 7 is here, 7.6, about 7.7, 7.7, alright, about 7.7, so 7.7, okay, let's see how many decimal do they read. Okay, it's 1 decimal in this case, 7.7 cm³. So also, use the values on graph, calculate the rise temperature which occurs when exactly, okay, the rise in temperature. Now first of all, what is the temperature at that point? Temperature is here, to a dotted line. Temperature is 33.2. 33.2 is the temperature, but it's not the rise yet, so you must calculate. So it's 33.2 minus what is the starting temperature? Starting temperature is 21.0. Before adding is 21.0. So I want to minus away 21.0 equal to 12.2 degrees Celsius. Alright, that's all. 12.2 units given behind. Okay, use an equation to show what's meant by neutralization. H plus equal state, hydroxide equal state, form water, liquid state. And this equation you can actually memorize. Okay, you need to remember this equation for neutralization. When excess acid is added to potassium hydroxide, solution changes from alkaline to acidic. Sample solution are taken out before and after addition of excess acid. Describe a test to be carried out on each sample to show that solution had changed from alkaline to acid. What test can you use? Now the fastest, the easiest way is to show a litmus indicator. Okay, there's blue in alkaline and red in acid. Alright, you don't need to remember all different indicators, just remember litmus paper blue. So test the solution with both red and blue litmus paper. Test solution with both blue and red litmus. So before it turns to acidic alkaline, that means the red litmus turn blue. And after you become acidic, is the blue litmus turn red. Of course, if you remember some other color indicator, for example metal orange, whatever, you can use that. Alright, or you can use universal indicator. But universal indicator has many colors. So if you use universal indicator, before you have to describe, like for example, it can be violet, indigo, or blue. After it become either orange, yellow, or red. Alright. Okay, the names of this element. N is nitrogen. Always refer to the periodic table, and please spell correctly. On the back, fertilizer is stated to be quick acting. Okay, what can you tell about solubility of this fertilizer? Quick acting means for the fertilizer to be absorbed by the plant, first of all, it must be in aqueous so that it can be in solution form. The plants, the roots of the plant can absorb this fertilizer, right? So in order for the fertilizer to be quick acting, means they must dissolve very fast. Okay, so what they tell about the fertilizer, it is very soluble in water. Okay, very soluble in water, because water is added to the soil, so the plant can actually absorb the water through the roots together with the nutrients. One chemical in the back is ammonium nitrate, and calculate relative molecular mass of Mr of the ammonium nitrate. So 14 for nitrogen plus 1 times 4 for hydrogen plus 14 for the next nitrogen plus 16 times 3. Alright, just add together. Answer is 80. Alright, and relative molecular mass, no unit. 80 will do, no unit. Okay, you write unit means you're wrong actually. Okay, so down here, you use ammonia to form ammonium nitrate, and tons of ammonia needed to form 240 tons of ammonium nitrate. Right? So from ammonium nitrate 240 tons, so 240, the ton is actually 10 to the power 6 gram. So in other words, 240 times 10 to the power 6 gram. So it's 240 times 10 to the power 6 gram over 80. So it's 3 times 10 to the power 6 mole. Alright, you take the mass given, divide by Mr, you get the mole. And the mole ratio is 1:1. So therefore, I have this number of mole of ammonia gas needed. So I will say NH4NO3 to NH3 is 1:1. So it's 3 times 10 to the power 6 to 3 times 10 to the power 6. So for this number of mole, the mass, I must find MR of the ammonia first. MR of NH3 equal to 14 plus 1 times 3, 17. And therefore the mass is equal to the MR times the moles. 3 times 10 to the power 6 times 17, which give me 51 times 10 to the power 6 gram equal to 51 ton. Because this 10 to the power 6 gram is equal to 1 ton, so it's 51 ton. That's all. The farmer tests the soil and finds the pH 6, and P requires high alkaline. So why this soil is not suitable for growing pea? Why? So P requires a slightly alkaline soil to grow well, but pH 6 means the soil is slightly acidic, and therefore of course it wouldn't grow well. Okay, so it is not good. So the pH is not correct and the plant cannot grow well. If you require alkaline soil, then you must have pH more than 7. In this case, you need alkaline means more than 7, but pH 6 means the soil is acidic, so it's not good for the pea to grow. And of course, name a chemical that you can add. Now this one you cannot forget is calcium hydroxide. Okay, this question is very common, asked many times over the years, so make sure you remember. So in terms of chemistry involved, the effect of this chemical has on the soil. This chemical is what? This is a base, right? Calcium hydroxide, which is this chemical referring to, is basic and will neutralize the acidic soil. And because it's basic, it can make the soil slightly alkaline, as well as making the soil slightly alkaline. Okay, so the effect is neutralizing and then making slightly alkaline. After the farmer has treated this soil, it's suitable for growing pea. He shakes a little soil water, treats the liquid with universal indicator. What color should it be? If it's slightly alkaline, what do you think the color should be? Answer should be ROYGBIV. So answer should be blue. Alright, it should be slightly alkaline, should be blue in color.